Yeah, hi students, very good evening everyone. Welcome once again all of you to Om Institute, and yes, this is the next session on the IIT Guwahati previous year question series. So as you know, we have been conducting some sessions around IIT Guwahati, previously conducted papers, because IIT Guwahati is expected to conduct a GATE 2026 examination. Okay, because we know that it's a 8-year cycle pattern, and previously is conducted the examination in 2018 and 2010. Okay, so we are discussing questions of multiple subjects. I have completed the questions of control systems. Last session we started signal systems, and I told you signal and system again will be covered in two different parts because multiple chapters are there, and at the same time, okay, EC, EE and IN, all the three branches. Okay, the questions I'm discussing, because it's a common subject, I'm discussing EC, EE and including instrumentation question also. Yeah, so very good evening everyone, and let's get moving ahead. Good evening Akhila. Okay. Yeah, so let's get moving ahead. Let's get started with the first question. Okay, so yeah, we will as you know that in the last session, signal system part 1, we targeted the question of fundamental properties of signals, fundamental classification of systems like linearity and time invariance, causality, etc., and then questions on convolution around LTI systems. All those cases were discussed in the last class, including some Laplace transform question also. Okay, and today we'll first start taking the questions of Fourier series and Fourier transform, later on moving towards Z transform also. Okay, but in both the years, the level of Fourier series and Fourier transform was very fundamental, very easy. Okay, it was very easy in both the years. So let's have a look into it. Okay, let's have a look into the session. Let's get started. This is the GATE 2018 instrumentation 1 mark question. Fx shown in the adjoining figure, okay, is represented by, okay, so basically the Fourier series, the trigonometric Fourier series expansion is written in front of you. Okay, what is the value of A naught? And A naught, okay, the DC component, okay, A naught, the DC component, normally in terms of AN, it should be actually written as A naught. This I will call this as a wrong expression of Fourier series. Okay, otherwise we write it as C naught. See, either this should be the DC component, which should be written as C naught, or it should be written as A naught by 2 actually. But okay, let's assume that the intent of the question is clear. The intent of the question is finding the DC component. I will call this as a wrong expression of Fourier series. Okay, yeah. So A naught plus summation 1 to infinity AN cos nx plus BN sin nx. Okay, GATE 2018 instrumentation 2 marks question, very simple for 2 marks. Why? See, there are two methods now. Okay, if you have to find, okay, A naught, C naught, or A naught by 2, which we usually call it as the DC term. Okay, there are the two simple ways. What are the two simple ways? Okay, I'll tell you here. I'll tell you both the methods here. Okay, what is my method number 1? Okay, if you have to actually calculate, okay, so if you have to calculate the DC term, okay, just keep looking here. Okay, so how can you calculate this DC term? Okay, number one, area under, it's like average value of the signal, also known as the average value. Okay, so it's like the area under 1 period. Okay, the 1 period here is 0 to 2 pi. Okay, so area 0 to 2 pi, or you can take the area from minus pi to pi as well, considering the period as 2 pi, minus t by 2 to t by 2 fx dx divided by 2 pi divided by the value of the time period. Okay, this is what integral for one time period, okay, divided by the time period. This is the basic DC component formula. This is what is the basic DC component formula. Okay, or the simple method number 2, dear, or the very simple method number 2. See, dear, what is that method number 2? Let me take you towards the figure. That this is mostly a observation question actually. For that reason I want to discuss the other approach. See here. Consider this picture here. Consider this picture, and let me copy it once again. And now see the picture here. As well. Okay, dear. Now you see both the pictures in front of you. Okay, let's say the other picture is not fx. I want to call it as f of x minus pi. Okay, shifted. I have just right shifted. You can do right or left shifting, anything. If you right or left shift by half a period, let me see if there is any symmetry. Okay, let me see if there is any symmetry. Now you see, dear. Okay, now you see, dear. So let me also define let me actually also define the let me call this only as the x axis, sorry, the y axis, the vertical axis. Say this is the vertical axis. Okay dear, let's say this is the vertical axis. Okay, now if you see the above and below picture, does it have any symmetry? Okay, forget this. Okay, now the new y axis has been drawn in front of you. The new y axis has been drawn in front of you. Now see, this picture is going from 1 to 1.5, whereas if you come to the bottom picture, -1 to -1.5. Okay, -1 to 1.5. Then after going to 1.5, it reaches -1 and -1 to 1.5. Okay, what is happening here? Then after -1.5, it reached +1. Okay, then going to +1.5. Clearly only a sign difference. Clearly only a sign difference is here. So what I am able to say, dear, to all of you, that when I shifted by half the period, f of x minus pi is just negative of fx. And those of you who know half wave symmetry, for you, you don't have to draw it. I am drawing for your convenience. Okay, pi here is t by 2 because the time period of the waveform is 2 pi, that you can clearly observe. But those of you who are clear about the half wave symmetry concept, you don't actually have to draw it. Okay, I am drawing just to give you the solution, just to explain. Okay, but you know, if you know half wave symmetry, you can observe. Okay, yeah, the picture, when I shift by half the period, the above and below the values, okay, after shifting half the period are just opposite in sign, are just having opposite sign. Clear? Okay, and whenever half wave symmetry is there, what about the Fourier series? Fourier series contains which harmonics? Okay, contains which harmonics? Okay, that you can recall. Okay, the Fourier series contains only and only odd harmonics. Only odd harmonics. Okay, that means there is not even DC also, no DC and no even harmonics. Okay dear, no DC, no even harmonics. That is what is the correct analysis. Okay, no DC and no even harmonics. Okay, so for that reason the answer is 0. There is no DC as well. Even if you integrate and solve, it's going to be 0. Why? Because see na, minus pi to minus pi, okay, to 0 and 0 to pi. Okay, when you integrate, both are going to come up as different area. I mean equal but opposite sign area. Okay, area under this looks equal, but one is positive, one is negative. One is negative, so the answer is going to be 0. Okay, if I want to write down here, if I want to complete the method number 1, as I have told you, okay, so this you can split as minus pi to 0 plus 0 to pi. Okay, and that is going to be some area A plus the other one will be minus A, and hence net answer will be 0 here as well. Okay, and this is what clearly is the method number 2, which is around half wave symmetry. Although first method is also simple, you can expect questions on DC component also, but I will prefer here to remember the second method because half wave symmetry is very important in Fourier series analysis and in the gate questions as well. Good evening, Vineet Kumar, right? Okay dear, yeah. Then let's go to the next question, if this is clear. This was GATE 2018 instrumentation 2 marks. Now see, GATE 2010 doubly 1 mark question. Simple question again. Second harmonic component of the periodic waveform given in the figure has an amplitude of. You have to talk about second harmonic component. It's a periodic square waveform. Okay, you can observe and say, but again, if I right shift, right or left in your hand, if I right shift by t by 2, half the time period is t. If I right shift by half the time period, then you will be able to see what is the correct analysis. Okay dear. See here, so if you shift it by half the time period, okay, here also if you take minus t by 2, so negative cycle will come up here and positive cycle which started from origin will go here, and very clearly, okay, this is t by 2, this is t, very clearly the +1 value here is -1, the -1 value here is plus 1, opposite in sign. So once again, for this waveform, I can call this waveform as half wave symmetric. Okay, and half wave symmetric means no even harmonic. It contains only odd harmonics. Okay, and the second harmonic, second means even. So second harmonic again 0. Second harmonic again 0. Option number A. The second harmonic is again going to be 0. Option number A is the correct one. Okay. All right, if this is clear, next question for you. Gate 18 EC 1 mark, fundamental Fourier series property. A fundamental Fourier series property. What is that? Let xt be a periodic function with the period t equal to 10. Periodic function with the period t equal to 10. Okay. The Fourier series coefficients for this series are denoted by ak. Okay. And xt is given as summation minus infinite to infinite ak e power jk 2 pi by tt. The basic Fourier series expression, the exponential Fourier series form. Summation ak e power jk omega naught t. The same function xt can also be considered as a periodic function with the period t dash equal to 40. So they are trying to change the period. Okay, how much is the period they have mentioned? Okay, with the period t dash equal to 40. Okay, it should be looking like same function. Okay. So same function means, okay, for reference, if I take the previous waveform example is a periodic square waveform. Okay, only thing is if you change the time period, okay, changing the time period is related with expanding or compression of the signal. See, if you compress or expand, the square waveform will remain square waveform, but only thing is time period may reduce or may increase. Correct, na? So expansion, compression or expansion does not change the periodicity of the signal, but it only affects the time period. Okay, so if they are telling that consider another similar function, same function, I mean the waveform should be same, but now consider it having a period of 40. Period of 40. This is 4 times t. This is 4 times t. 4 times t means expansion has occurred. Expansion has occurred, and you can represent this new function also as x of t by 4. Okay, x of t by 4. So same function can also be considered as a periodic function with the period 40, and now for this function let the Fourier series coefficient be bk. Okay, when the period is taken as t dash, that is xt by 4 signal, okay, the Fourier series coefficients are bk. Now they give a data. Suppose summation modulus ak is 16. What is summation modulus bk? What is summation modulus bk? What is the time? Very, very important time expansion property. So for xt by 4, okay, the Fourier series coefficients are simply ak. Around this property, multiple times questions has been asked in GATE. Even in the current year 2025 in EC, there is a question around, okay, around the expansion or compression of a signal. What happens when you expand or compress a periodic signal? Time period will change. So fundamental frequency will change. Okay. But Fourier series coefficients do not change. Fourier series coefficient do not change. Okay, if I have to write down a result, x of at, okay, so I'll put it this way. So if you start with a signal xt which has the Fourier series coefficient ak, x of at, okay, will have the same Fourier series coefficient ak. Have a look into it. It will have the same Fourier series coefficient as xt. One of the important and very, very useful and useful way to questions also. Okay, important in terms of questions also. Good evening, ABD. Okay, dear. Right. So Fourier series coefficient do not change. Now because Fourier series coefficient do not change, whatever is the summation mod ak is same as summation mod ck. Okay. So this also will be 16 only. What is there? Option number C. This also will be 16 also. This also is going to be 16. Clear, everybody? Will be 16 only. Same. That's why it's a fundamental 1 mark question. Okay, if you know that expansion or compression, time scaling property for Fourier series. Next question, GATE 2010 EE 2 marks question, simple one on Fourier transform. xt is a positive rectangular pulse from t equal to -1 to t equal to +1 with unit height as shown in the figure. What is the value of integral mod x omega square? So basically integral mod x omega square takes you to the Parseval's theorem. Okay, takes you towards the Parseval theorem. Because what is the Parseval's theorem? If I write down and recall the Parseval's theorem for you separately, okay, What is the Parseval's energy theorem or Parseval's energy relation, dear? The Parseval's energy relation, okay, which says that the energy of a signal as calculated in time domain, okay, for real signal is integral. Parseval's theorem is also for real signals only. Integral x square t dt is also equal to, in the frequency domain, integral 1 upon 2 pi integral minus infinite to infinite modulus x omega square d omega. Correct? What? This is what is the Parseval's theorem. This is what is the Parseval's theorem. Okay, dear. So, using the Parseval's theorem, so as I told you, this expression has given me the hint about the Parseval's relation. Okay, so I want mod x omega square d omega and waveform is xt given. So, what is mod x omega square d omega from this relation? I can write down here only. Okay, so as per the Parseval's relation, this relation will be 2 pi integral x square t dt. Okay, 2 pi integral x square t dt, and what is integral x square t dt? Is the energy of the signal, correct? So this is equal to 2 pi into the energy of the signal xt. This is simply equal to 2 pi energy of the signal xt, correct? Now what is the energy of the signal xt? What is the energy of a triangular pulse, rectangular pulse? Very, very simple. Last session also we have seen, call this as amplitude A and call this as the total duration, because the energy of a rectangle pulse only is amplitude amplitude square into duration, correct? Na? Amplitude square into duration. So the answer 2 pi, okay, energy, I am using the formula A square d for rectangular pulse. Okay, so 1 square into duration minus 1 to 1 is 2 units. So 2 pi into 2, 4 pi. Answer is D. Answer is D. The correct answer is D. Have a look into it. The correct answer is simply equal to the 4 pi. Yes, Akhila, correct answer. It's going to be option number D, 4 pi. Okay, basic questions on Parseval theorem. GATE 2010 EE2 mark question. Next question. Okay, GATE 18 2 marks question. Okay, GATE 18 2 marks question. EC. I think I forgot to mention here EC 2 mark, but simple one. Fourier series, Fourier transform property. The Fourier, and not only property, it's one of the basic Fourier transform relation. Even not the property is also not required. Okay, the Fourier transform of a continuous time signal is given as x omega equal to 1 upon 10 plus j omega whole square for omega minus infinite to infinite. So you just have to recall one common formula, not one a rare formula, common formula, 1 upon a plus j omega whole square. Okay, and that is the formula for t e power minus a t u t. This is what is the formula if you recall. Okay, the problem is solved. T e power minus a t u t Fourier transform is 1 upon a plus j omega whole square. This formula applicable if a positive, and a is 10 here, of course. As per the Dirichlet's condition for convergence, we get this condition, a positive. Okay. Yes, Pratap, correct answer for the previous one, that was 4 pi. Okay. Yes, dear. Okay, so 1 upon 4 plus j omega, 1 upon a plus j omega whole square is what is the formula you use. Okay. So if x omega is given to you, as 1 upon 10 plus j omega whole square, so what is the xt? T e power minus a t. What is a? 10. Okay, so t e raised to the power minus 10 t ut. T e power minus 10 t ut. T e power minus 10 t ut. Now the question is, what is the value, okay, of modulus ln xt at t equal to 1? Okay, before we take log or something, if I just substitute t equal to 1, what is the value I will get? If I substitute t equal to 1, I will get the value 1 into e power minus 10. Unit step value will be 1 only because positive time is given. Okay, so e power minus 10. Okay, e power minus 10. So hence, directly writing the value of this expression. Okay, modulus of ln xt. Okay, xt is e power minus 10 at t equal to 1 required, na? Okay, and hence ln e power minus 10 is minus 10. Modulus of minus 10 is 10. Your answer is 10, dear. Have a look into it. Your answer is 10. Your answer for the question 10. An NAT type question, final answer being 10. Okay. Yes, Akhila, correct answer 10. So for simple one, I'll say for 2 marks it is a relatively simple question, because Fourier series and Fourier transform is a topic which can produce good questions, and in GATE recent years also you can find good questions onto it. But as I told you, in 2010 and 2018 IIT Guwahati years, Fourier series, Fourier transform, both questions were there but very fundamental in nature. Okay. Okay, yeah, this is still a decent question, but again, if you have the basic knowledge of Hilbert transform, this question is solvable quickly. The input 4 sinc 2t is fed to a Hilbert transformer to obtain yt, okay, as shown in the figure below, right? Hilbert transformer, also known as the pi by 2 phase shifter. If you just recall the Fourier transform, right, and rather, if you only recall the magnitude, Hilbert transform is a all pass system, that magnitude domain information itself will do. Okay, come on, think about this. Come on. Okay, it's a all pass system. If you use this much fact also, your done is done, your task is done. Yes. Okay. So yeah, let's continue. Hilbert transformers, as I was mentioning, if you use the frequency response, or basically use the knowledge that it's all pass system. See, because for Hilbert transform, h omega, the frequency response is given by minus j signum omega. Okay, minus j signum omega. So actually, let me write it here completely. Okay, that is the most important point to be used here. So for Hilbert transform, let's say the frequency response is h omega, and as I'm mentioning, it is minus j signum omega. So if I open this h omega, it is minus j signum omega. Now signum we know, for positive value signum will be 1. Okay, so if omega greater than 0, signum 1, so only minus j is left. For negative value, signum will be minus 1, so minus j into minus 1 plus j. And then you can, respectively break it into the phase terms. You can call the first expression as e power minus j pi by 2 and the second one as e power j pi by 2. It only brings a phase minus pi by 2 or pi by 2 based on the frequency. Okay, based on the frequency. But eventually at the end, e power j theta magnitude is 1. E power j theta magnitude is 1. So if you talk about the modulus of h omega, the modulus of h omega is 1 for all omega. The modulus of h omega, this is the important point. Let me write it here. Okay, let me write it here. Let's consider this point here. So what I'm trying to tell you is, modulus of h omega equal to 1 for all omega. So if I use this knowledge, then see the output of any system in frequency domain. Okay, question is on integral minus infinite to infinite mod yt square. Okay, mod yt square. That's like energy. This question is energy of the output. This is the energy expression. Na? We know this. This is the energy of the output. Okay. What is the output Fourier transform y omega is given by input into frequency response x omega h omega. So in terms of magnitude also, it is going to be modulus of x omega into modulus of h omega. Okay, but what is modulus of y omega is modulus of x omega, because modulus of h omega dear is 1. Modulus of h omega is 1. So modulus y omega simply means modulus x omega. Modulus y omega simply means modulus x omega. Correct, na? Modulus y omega is same as modulus x omega. Okay. Now, if this is the correct information, that means because the energy, Parseval's relation, as per Parseval's, you can say that, okay, if both the spectrum are equal, then integral mod y omega square d omega is equal to integral mod x omega square d omega. Okay, is integral mod x omega square d omega, correct? Okay, so now if I apply the Parseval's, my actual question is integral modulus of yt whole square dt, that is the energy of yt, and as per the Parseval's relation here, I will write it as integral modulus of y omega whole square d omega. But this question becomes now simple because modulus y omega whole square will be same as modulus x omega whole square d omega. But what is x omega now? Xt is given and it's a very common function given. It's a very common function given. Sync and sampling, sync or sampling, anything given. Okay, 4 sync 2t. It is given as 4 sync 2t. 4 sync 2t. Or you can call it as 4 sampling 2 pi t. Sync theta is sampling pi theta. Sync theta is simply sampling pi theta, correct? Okay, so now let's use the very common Fourier transform pair, common and important. So whenever sampling at is given, dear, what is the Fourier transform? For sampling at, the Fourier transform is pi by a, rectangular function, rectangle omega by 2a. Pi by a, rectangle omega by 2a. Okay, so for this given xt, what is the x omega? 4 sampling 2 pi t. So sampling at, pi by a is 2 pi, rect of omega by 2a, omega by 4 pi. Pi cancel, 4 by 2 is 2. So it's going to be a rectangle of twice the amplitude. Okay. So dear, for your convenience, not required properly, but yeah, for your convenience, if I have to just draw this particular rectangle, see, rectangle omega by 4 pi. Okay, the total width of the rectangle is 4 pi. Total width of the rectangle 4 pi, located from minus 2 pi to 2 pi, and what is the height of the rectangle is 2. Okay, and then now you can complete the answer here. 1 upon 2 pi integral mod x omega square d omega, considering rectangular pulse, again amplitude square into duration, 2 square into duration 4 pi. Okay, so 2 pi from here also cancel, 2 square into 2, answer for the question will be 8 units. Answer for the question will be 8 units. Yes, Pratap has the answer, correct one. Answer for the question is going to be 8 units. Answer for the question is going to be 8 units. Okay dear, complete. Answer for the question is 8 units. Done. Okay. Then I have the next question ready for you. Oh, a definition question basically. Gate 18, EE, 1 mark question. A continuous time input xt is a eigenfunction. Now what is a eigenfunction? Where the output is just the multiple of the input, proportional to the input, no other change. Okay, so if the input is xt, output is lambda xt or k xt, option number A, where k is known as the eigenvalue. That's a definition of the eigenfunction. You study in maths also, you study in signals also. Okay, output is just proportional to the input. Okay, right. So it is k into xt. K into xt. Simple. That's a definition of the eigensignal. Okay, next question. Okay, sampling. Okay, a sampling based question. A band limited low pass signal xt of the bandwidth 5 kilohertz is sampled at the sampling rate fs. Sampled at the sampling rate fs. The signal is reconstructed using the reconstruction filter HF, whose magnitude response is shown to you. Whose magnitude response is shown to you. What is the minimum sampling rate? What is the minimum sampling rate in kilohertz for perfect reconstruction of xt? For perfect reconstruction of xt. See, let me just copy this particular picture first. Okay, yeah, rather let's also revise the sampling process. So what is given? A low pass, band limited low pass signal of bandwidth 5 kilohertz is to be sampled, okay, at the sampling rate. Okay, so let's say this xt will have some Fourier transform which I am calling it as x omega. Okay, and that x omega is band limited up to 5 kilohertz, you can say. Okay, now that is sampled at a sampling rate fs. At a sampling rate fs. What is the Fourier transform of the sample signal? See, how do you actually consider the sampling process? Okay, the basic idea of the sampling process is important to solve this question. It's a GATE 2018 2 marks question. Pratap has the answer 13 kilohertz. Okay, all right, great, answer is coming up already. So see, xt. Okay, we first multiply, okay, by the periodic impulse train pt, okay, to get the sample signal, which we call it as xst. Okay, and then for perfect reconstruction also they are telling. Okay, so what we normally do is then we pass this through a filter, normally a ideal low pass filter, but here it is some other filter mentioned. Okay, so to reconstruct we pass this xst, so that if the sampling process is perfect, the recovered signal, okay, let me call it as a recovered signal, but the recovered signal is desired to be the original signal if the sampling has been perfectly done. Okay, is equal to xt ideally. Ideally, this is what is desired. XRT should be equal to the xt, correct? Okay. Now, dear, what is this xst and the Fourier transform? That knowledge is important. Okay. xst, which is xt into pt. Okay. Xs omega. I'll give you the final formula on solving. How do we solve when signals are multiplied? Okay, it leads to convolution in the Fourier domain, x omega, convolution with p omega. P omega is the Fourier transform of the periodic impulse train, and on solving, we will not derive complete sampling here, otherwise the whole time will go on. Xs omega is 1 upon 2 pi. Okay, finally the formula that turns out to be 1 upon 2 pi summation, sorry. On solving, the final formula for xs omega turns out to be summation of x of omega minus k omega s. Summation x of omega minus k omega s for k being minus infinite to infinite. Okay, xs omega turns out to be summation minus infinite to infinite x omega minus k omega s. Okay, where x omega, now what is the x omega? They have just mentioned that xt is having bandwidth 5 kilohertz. So we can assume it's a band limited low pass signal given. Na? Xt is a band limited low pass signal. So we can assume some x omega. Okay, so let's say the signal xt has the Fourier transform x omega, and the Fourier transform sketch. The Fourier transform sketch can be considered this way. Step by step explaining it to you. So the Fourier transform sketch, okay, of x omega, okay, consider anything like this, okay, and taking it on f scale. Let's say this is f, and let's take it in the f domain only. Let's take it in the f domain. Suppose this is x of f, okay. Suppose this is x of f. Okay, so it is band limited up to 5 kilohertz. 5 and minus 5, assuming that this frequency is in kilohertz. Okay, band limited low pass, it is only up to the low frequency of 5 kilohertz, correct? This is what is the Fourier transform of xt. But what is the Fourier transform of the sample signal? Just now I told you, writing in the f domain only, xsf is given by summation x of f minus k fs. Okay, where fs is the sampling frequency. That is what we need to find. What is the sampling frequency? What is the minimum sampling frequency? What is the minimum sampling frequency? Okay, so considering this, okay, see, if you dear want to open this expression, so suppose if you take k equal to 0, this is simply xf. If you take k equal to 1, it is x of f minus fs, right shifted. If you take k minus 1, left shifted. Then twice right shifted, twice left shifted. Okay. So what I have done for you, xf is given to you. Xf I have given to you. Okay, that is from minus 5 to 5. That anyways will come. But what will also come? Okay, what will also come? Okay, not only this xf, but what will also come is f minus fs, right shifted. Okay, right shifted by how much? Right shifted by fs. Okay, if this is centered at 0, this is 5, this is minus 5, this will be centered as fs, and this is going to be fs plus 5, and the left point will be fs minus 5, and etc. They will be twice left shifted and twice right shifted. All the versions will be there. Clear? Now let me place the filter in this picture only. Let's not take it separately. I'll just copy this filter here. And what is this filter given to you? It has a constant gain k, okay, up to the frequency 6, okay, up to the frequency 6, and beyond that the gain tapers and it becomes 0 at 8. Okay, so let me just copy this. Let me copy the filter information given to me. It is constant up to the 6, okay, and then it decreases something like this. Okay, na? Now see, it is constant up to 6. Oh, it is constant up to the 6 and decreases up to the 8. Left side minus 6 and minus 8 for perfect reconstruction. Now what you want in perfect reconstruction, the XRT should be XT. That means the recovered Fourier transform should be X omega. Na? Either you solve in time domain or frequency domain. Okay, so what is the recovered Fourier transform? In the frequency information you want this XF. Okay, that means you want only this much, but if you take these components also, okay, aliasing will happen. Okay, if you take the higher frequency components also, so you don't want these frequency components to come up. That means this frequency 8, after which the gain of the filter is 0, should be before fs minus 5. That means any frequency from fs minus 5 or onwards will not be passed. Okay, will not be passed. Okay, so the output of the filter, suppose the output of the filter is XRF, okay, should be equal to XF. That is what you want, na? XRT should be equal to XT, or in frequency domain XRF should be equal to X of F. So XRF will be equal to X of F from this picture. See this picture very clearly. XRF will be equal to XF if this 8 falls below Fs minus 5. So that any frequency component of this particular portion will not come up, and hence you can say Fs is greater than, or worst case, boundary case 13. I mean, this can go maximum up to here. But if this goes like this, then at the output of the filter, some frequency component, okay, will come, okay, from the higher frequency side as well, right? So Fs is greater than equal to 13, solving this. Okay, 13 what? Kilohertz. The unit were in kilohertz. So what is the minimum sampling rate? Minimum is 13. What is the minimum sampling rate, dear? Minimum would be 13. Take this and let me know in case if you have any doubts. In case of any doubts, just let me know. Just a second. Yeah. It's a basic question on the concept of sampling. See, sampling in GATE has produced even many more good questions. Okay, this is also good question, but on the fundamental understanding of the sampling process, if you know the concept, because many students in sampling only study the Nyquist rate formula and all. Okay, that will be able, from that you will be able to solve only very basic questions, but not all. Okay, done. Okay, next question. Alright, DFT. Let xk is equal to k plus 1, 0 less than equal to k less than equal to 7 be the 8-point DFT of the sequence. Let this be the 8-point DFT of the sequence xn, where xk is summation xn e power minus j 2 pi nk by capital N, the basic DFT formula. What is the value of summation x to n? Property. If you use the correct property of DFT, this is going to be solved easily. Otherwise, it's a good question. See, summation x to n. What is this summation x to n? Okay, the question is asking you this expression. Let's take this expression. Correct, this is the question, and if you open this expression is summation for n equal to 0. Okay, yeah, let me open the summation actually. So n equal to 0, x0, for n equal to 1 it is x2, for n equal to 2 it is x4, dear, for n equal to 3 it is going to be x6, correct? Okay, fine. X0 plus x2 plus x4 plus x6. This is what it is. This is what it is. Okay. Yeah. But you know, if you use the basic property of the DFT, okay, xn has the DFT xk, okay, where x of 0, okay, the first ordinate is always given by summation of xn for all values of n, okay, and the central ordinate x of n by 2 is given by summation minus 1 power n into xn, minus 1 power n into xn. So using these properties, dear, if I use capital X0, as I told you, it is summation of xn. Okay, here it is a 8-point DFT given. Okay, so n is 0 to n minus 1, 0 to 7. That means it is x0, keep looking into it, plus x1 plus x2 plus x3, dear, till x7. Okay, but if you use the x4 central ordinate, okay, summation minus 1 power n. Now whenever you put minus 1 power n, it is going to be alternating in sign, because minus 1 power odd is negative and minus 1 power even is positive. Okay, so you start with minus 1 power 0, that is going to be positive only, minus 1 power 0 is 1, then minus of x1, minus 1 power 1, then minus 1 power 2 will be positive, the plus x2, then minus of x3, etc. The alternate plus minus till x7. Okay, so because it is alternate plus minus, dear, because it is alternate plus minus, if you add this x0 and x4, what is going to happen? If you add the x0 and x4, what is going to happen? Okay, this minus x1 plus x1, minus x3 plus x3, all this will cancel, but x0 plus x0 will come 2 times. x2 and x2 will come 2 times. Okay, then next term will be x4, only even values, and then next is x6, and that is what my question is. So what is x0 plus x2 plus x4 plus x6? This should be equal to, so this 2 I will divide on the other side, this should be 1 by 2 of capital X0 plus capital X4. What is DFT XK? The DFT XK expression is given. You see the question, you read the question, what is XK? The XK is given as k plus 1. The XK is given to you as k plus 1, correct? K plus 1. Okay, so that means this first value k plus 1, 0 plus 1 will be 1, 4 plus 1 will be 5. Okay, so 6 by 2, final answer has to be 3. The final answer is 3. That's it. The final answer is 3. NAT question, answer is 3. 6 by 2. Yeah. Let me know for any doubts or something. Hi Sairaj. Correct? Yeah, next question. Okay, a fundamental question, Z transform. Consider the Z transform 5Z square plus 4Z inverse plus 3, 0 less than mod Z less than infinity. What is the inverse Z transform? Okay, Xn, basic Z transform formula. This question is on basic Z transform understanding, right? Yeah, Ritvik, we can meet at the institute. So I will be there in Hyderabad yeah, from Tuesday onwards. Okay, so you can meet me if you want. Yes, you can meet me. Okay. Okay. So see dear, basically what is the basic Z transform expression is given by the formula summation xn z power of minus n, summation xn z power of minus n. Okay, z power of minus n. So whenever you have, suppose z power of minus 1, z power of minus 1, so what is the coefficient? It should be x of 1. Okay, now this is constant, this will be x of 0, because if you take n0, z power 0, then only you get the constant term. Okay, now z power plus 2, Z power plus 2 will come if you choose n as minus 2. If you choose n as minus 2, so what about this value? You can call this value as the value of the signal at minus 2, correct? Okay, and hence the signal xn has only 3 samples, and what are the 3 samples? I am able to write them. Xn is given by value 5, okay, then directly the value at origin is 3, okay, so this will be blank, then the value at n equal to 1 is 4. That's what this is, origin 5034. Can we write it like this? Or you can write in the impulse form also, options are in impulse form. At origin the value is 3, at n equal to 1 the value is 4, at n equal to minus 2 the value is 5. So one value have to be taken as 0, has to be taken as 0. Okay, these are the corresponding values of n, minus 2, minus 1, 0, 1, minus 2, minus 1, 0, 1. Okay. So what is there? What is the correct value of xn? Okay, in terms of impulse, the impulse at origin will have amplitude 3, 3 del n will come, right shifted impulse 4 del n minus 1, and then 5 del n plus 2, option number A itself. This is left shifted impulse, na? One by one you can represent this by, 3 del n, impulse at origin, impulse at n equal to 1, we write it as delta n minus 1, how much amplitude? 4, so 4 delta n minus 1, and this impulse is the impulse at n equal to minus 2, so delta n plus 2 with the amplitude 5. Option number A, what is there? Simple, na? Option number A, Akhila, correct. See, fundamentally, Pratap, you may try to construct xn, but that will go very lengthy. One of the ways trying to construct xn from the IDFT formula, but that will go very lengthy. Okay, but the property that I have used is one of the very repeated. See, not only this, onto the same property that there have been similar related questions in the gate. So, there is a very fundamental property, x0 and xn by 2. I call it as the first and central ordinate property. Whenever I cover DFT, I call these properties as important also, the first and central ordinate. Even sometimes if there is a question xn given, find the DFT, sometimes with the knowledge of these two properties, okay, we are able to match options. So that is why these two properties are important. You must remember them separately. Otherwise the question goes lengthy. Okay, next question, dear. Gate 10 EC 2 marks. Okay, a basic question on the understanding of ROC of the Z transform. On the ROC of the Z transform, have a look into this question. The transfer function of a discrete time LTI system is given to you, HZ, and consider the following 3 statements. The system is stable and causal for the given ROC, then system is stable but not causal for the another ROC, and system is neither stable nor causal for the third ROC. That's it. Okay, let's also confirm whether the ROC is given are valid or not. Okay, and ROC knowledge is dependent on the poles. On the poles, and what is the HZ given? Can you factorize and create the poles here? Okay. Okay, let's check this. Okay, so the numerator is 2 minus 3 by 4 Z inverse divided by denominator. Okay, now think 3 by 4 and 1 by 8. Okay, 3 by 4 and 1 by 8. The central term we know is addition, the last term is now be obtained by product of the factors. Okay, so you can simply think about 1 by 2 and 1 by 4. 1 by 2 plus 1 by 4, 3 by 4. 1 by 2 into 1 by 4 is 1 by 8. Okay, so we can factorize the denominator as 1 minus 1 by 4 Z inverse, 1 minus 1 by 2 Z inverse. Okay, see 1 by 4 plus 1 by 2, 3 by 4 Z inverse. Now when you multiply 1 by 4, 1 by 2, 1 by 8 Z power minus 2 will come, correct? So what are the poles? Okay, so the important information is the poles. Okay, the poles. First one, if you solve, you will get Z inverse equal to 4, so Z is 1 by 4. Second one, Z inverse equal to 2, so Z equal to 1 by 2. These are the two poles, 1 by 4 and 1 by 2. And for that reason, dear, for that reason the ROCs are given around 1 by 4 and 1 by 2, because ROC is confined by poles. Mod Z greater than 1 by 2. See, right sided ROC, causal. Okay, and is it stable? For stability, unit circle has to be included. Okay, so let me solve the answer here only. See, let me solve the answer here only. Mod Z greater than half. Okay, exterior ROC. Mod z greater than half is exterior ROC. Exterior of a circle. Exterior ROC means causal. Second, the second point to be written here is, does it include unit circle? Mod z is greater than half. If it is greater than half, can it be equal to 1? Yes. Okay, yes, it includes mod z equal to 1. Okay, so stable. What is mod z equal to 1? Unit circle. Whenever the ROC includes unit circle, the system is stable. The first statement is true. Second, it is stable for not causal. Okay, the second says stable but not causal. Okay, not causal. Yeah, definitely non-causal. Okay, this is interior ROC. Okay, definitely it is going to be not causal. That is okay. Let me rather write it here. This is not going to be causal. Okay, but also unstable. Because when you say mod z less than 1 by 4, okay, mod z cannot be 1. Mod z, or I can write this way, mod z equal to 1, not included. Unit circle not included here. Because mod z has to be less than 1 by 4. So how it can be 1? No, na? The third one, again, it's not an exterior ROC, so non-causal. This also will be non-causal. Okay, and again mod z equal to 1, not included, because mod z is between 1 by 4 to 1. Where is 1 by 4 to 1 by 2? Where is 1? Not possible. Not included. So not included means unstable. So third is also correct statement, neither stable nor causal. Second is wrong statement. So option number then C, both S1 and S3 are true. Both S1 and S3 are true. I hope you are now clear with this. Okay. If a system is causal, the ROC must be an exterior ROC, exterior of a circle, mod z greater than something. If a system is a stable system, then ROC should include the unit circle. Mod z equal to 1 should be inside the ROC. These are the two conditions. These are the two conditions. Okay. And not only in GATE 10, around these conditions multiple times in the previous year, different questions, but around using these conditions, the ROC of causal system is exterior of a circle, mod z greater than something. Okay, that too greater than the outermost pole, because we know pole cannot come inside a circle. So if you are going greater, then you have to go outside the outermost pole only, out of the largest pole. And then for a system to be stable, the ROC must include the unit circle. One more condition, important, not required here, but yeah, let me tell you. If a system has to be both stable and causal, then a system can be both stable and causal if all poles are inside unit circle. So if you combine the stability and causality condition and think, it boils down to the pole. See, now for this question, why statement number 1 is true? The system is combined stable and causal. It will only be possible for those systems where all the poles are inside unit circle. See, all the poles, 1 by 4, 1 by 2, both are less than 1. So both the poles are inside unit circle, and hence system can be stable and causal both. What happens if all the poles are not inside unit circle? Can it not be stable then? Yes, it can still be stable, but it will be non-causal. I'll tell you, if all the poles are not inside unit circle, dear, what will happen? It may be stable alone, it may be causal alone. Both independently are possible, but it cannot be combined stable and causal. Clear, everybody? Any doubts, you can let me know. Okay. And then next question, GATE 18 EC 1 mark question. GATE 18 EC 1 mark question. Come on, take this question and answer it. A discrete time all pass system has two of the poles at 0.25 angle 0 degree and 2 angle 30 degree. Which of the following about the system is true? Okay, discrete time all pass system. What is the condition of poles and zeros of all pass system? It has symmetric. Okay, symmetry about what? Symmetric about unit circle, poles and zeros. Okay, what does this symmetry means? What does this symmetry mean? Symmetric about the unit circle. If one is outside, one is respectively inside. Okay, so what does this symmetry mean? Okay, so if I say that there is a pole at z equal to p, there will be a 0. Let me better write it here. So this symmetry means that, understand, this symmetry means that if there is a pole at if there is a pole at let's say z equal to z naught, I'll call it like this, then there should be a 0 at z equal to 1 upon z naught conjugate. 1 upon z naught conjugate. That is what is the, in the discrete time domain, the relation between the pole and 0. Okay, pole and 0. Okay. So that means if it has the pole, okay, if it has the poles given to you 0.25 angle 30 degree and 2 angle 30 degree, there will be zeros at, okay, 1 upon, so see, first one is real, there is no phase given, na? Okay, first one is real only. See this results here. The first one is real. So 1 upon 0.25, okay, angle 0 degree, that will be real only. And the second one, 1 upon 2, that is 0.5, okay, for conjugate, angle is going to become negative. So the other one, there will be 0 at 0.5, angle minus 30 degree. Okay. Okay, so it has 2 more poles. No, it can have zeros at these locations given, but not the poles. But not the poles. Okay, symmetric poles and zeros. Rather, it will be taken, there is no real condition mentioned, na? The system is real, so it will be at 30 degree only. Yeah, see, furthermore, one more condition is there. If a system is real, na, if a system is real, that is not mentioned here, then the poles and zeros which are complex, they will always occur in conjugate pair, but there is nothing mentioned about reality. Okay, so conjugate pair here existing, we can't say here. Okay, so definitely option number A is not correct. Option number A is not correct. Now, it is stable. Now see, option number C and D, constant phase response over some frequency, constant phase response over entire Z plane. No, all pass system means constant magnitude response. A basic definition, forget the pole and zero, that is a symmetry condition. Okay, when I say all pass system, all pass, so it has the, not the constant phase response, it has the constant magnitude response, constant magnitude response for all frequency. Okay, so C and D are also correct, incorrect. C and D are also wrong. Okay, now it is stable. Option number B is left. Of course, that has to be correct, but understand it is stable only when the impulse response is two-sided. It is stable if the impulse response is two-sided. Now see, it is stable. Okay, let us understand this way. It is stable. Let's understand this point. Option number B. Okay, I'll explain it here only. Let me move aside. It is going to be stable as I just explained to you if what? If ROC includes unit circle. So what should be the ROC? Okay, the pole, see the magnitude of the pole is 0.25 and 2. Okay, okay, the ROC possible is mod z greater than 2. Okay, but then unit circle will not come. Mod z less than 0.25, then also unit circle will not come. So you can take the ROC 0.25 less than mod z less than 2. If you take the ROC from 0.25 up to 2, from 0.25 up to 2, so 1 will come, na? Unit circle means mod z equal to 1. Unit circle means mod z equal to 1. Okay, so ROC can be taken from 0.25 to 2. Okay, that means ring shaped ROC. That means what it is? A ring shaped ROC, and the ring shaped ROC is always for a two-sided signal. Okay, so it will have a two-sided impulse response. It will have a two-sided impulse response. Option number B, this is the correct answer. Option number B is the final very correct answer. Okay, so easy conceptual question. Okay, You have to connect the dots, you have to connect the several points. Okay. Right. Yeah, let me brief you the important information, guys. If you want to dedicatedly prepare for GATE 2026, okay, in a very competitive atmosphere among hundreds of students, also clearly live face to face in front of the faculty, the top faculty team for ECEE across the nation with OM Institute. Okay, so you can register and join our new offline batches. For EC, the new offline batch just started 11 July. Okay, so you can even join for this, and we will announce the next batch also soon. For EE, okay, the new offline batch is going to start July 21st. The new offline batch for EE starts July 21st. The fees for offline 65,999, but currently it is priced at 54,999 with some special discounts as mentioned in front of you. But for any queries, okay, you can immediately contact 95156 94053, right? Okay. In case, if you can't travel to Hyderabad at any chance, or if you're a college going student, cannot travel for offline, want to still study, having the best content by the same faculty team, okay, and having slight feel of offline in a live manner, you can join our online live course. Okay, online live course is available for GATE 26 and GATE 27 with 1 and 2 years respective validity. The fees being currently priced at 19,999 and for 2 years 28,999, right? And to, if you want some more benefits in the live course, so OM Institute this month on July 20, that is 20th of July, okay, brings to you the OM online scholarship test. Yes, the OM online scholarship test, okay, that is going to be conducted on 20th of July, okay, that is next Sunday, 6:30 p.m. to 7:20 p.m. a 50 minutes examination, fundamental syllabus which is mentioned in front of you for EC and EE, okay, but if you excel in this examination, you get huge benefits. Yes, if you perform and if you are in the top 3, you get 100% scholarship. Rank 4 to 10 will get 60% scholarship, and etc. Based on your performance, the scholarship amount is mentioned. You can register for this test. It's a free registration. The QR code is available on screen. You can just scan the QR and get yourself registered. Even the online test is free, but registration is mandatory before going to the test. Okay, dear. If you are preparing for AE, or if you are willing to prepare for AE, the new batch for AE, that is Transco and Discoms exams for AP and Telangana, starts July 15th. July 15th. Okay, that's it. So like the other sessions, control systems and signal system part 1, also I have shared you the PDF in my Telegram group. If you are not connected in my Telegram, you can connect using this link, the name mentioned in front of you, and I'll be sharing you the PDF of signal system this video also. Okay, but as I told you, all the PDFs that I will share, okay, is for the students who are watching it. If you watch, then only you need the notes, and for that reason I'll keep the PDF as password protected. If you are watching, you have this password, okay, keeping the simple password as in the earlier part, IITG SS2, IIT Guwahati Signal and System Part 2, this is the code. Okay, so you can download the PDF, but the PDF will be password protected, the password everything in small, IITG SS2. Okay, you can save this password with you. Okay, I'll share you the PDF tonight or maybe by tomorrow in the Telegram as the link mentioned. Okay, dear. So yeah, we'll be coming up with some other subject now. So controls and signals, all questions of 2010 and 2018, including ECEE-IN, we have discussed in the previous sessions. Okay, dear. Okay, bye bye. Let's meet you in another session. Thank you. Stay safe and take care of yourself.